students. Today we'll start a new chapter, very interesting chapter, that is force and laws of motion. Okay, so here force and laws of motion. This term force is very well known to you because whenever you are just moving any object, at that time you are applying force. It may be pull or push, right? So in this lecture we will discuss force and laws of motion. So here two topics we will discuss here. Force, what is force and what are the different types of force also we will discuss. And here force, push or pull, balanced or unbalanced, that also we will discuss. Let's start this. Now here in this picture you can see that one man, there is some string here, and it should be very strong string because I think that this mass of this object is very high. Mass of this object is very high. Okay, so this object he has to pull. So that's why he is just using one string here. Now that means what? He is applying some force to lift this object. Now great scientist Aristotle famously represented a force is anything that causes an object to undergo unnatural motion. That means what? You are applying the force and at that time the object will move, okay, or the object will gain the motion, and it can be unnatural motion. Okay, next, gravity and force, there is some relationship. Now force, one thing, whenever this term you heard, one thing you are thinking always that force means I have to apply some force or I have to push some object, right? Another thing, if you just think about the gravity, in this earth, all of us, we are standing in this earth. That means some gravitational force also you have. That's why we are attached to the earth surface. Once Sir Isaac Newton observed that just there was some apple tree, and this story I think all of you know. One apple that falls down, okay, that falls down from the earth. This is the ground. So that apple that fall on the ground. So Sir Isaac Newton, first scientist who studied the gravity and the force. Just a minute, I am taking the highlighter. Okay, so first scientist who studied the what? Gravity and force. That means there is some pull or push, what you can say, that is not the simply force. There is another force which are acting on all the objects that present on the earth surface. That's why the apple will move downward. If you are throwing one ball upward, on that, after some time you can see that it will fall on the ground. If you are just throwing one ball, you can see that after moving like this curvature, it will fall on the ground. Like this is ground, so it will fall on the ground, right? So this is due to the gravitational force. So any kind of force that is just push or pull, that may be defined as the force. But apart from this, you have another force always you are facing in your daily life, that is the gravitational force. Okay, in this picture you can see that here Chintu and Pintu, these two persons one block is here and one person just he has to pull this thing and he has to push this thing, right? So push and pull are opposite forces. And in case of your any showroom, you can see in the door, glass door, it has been written pull or push, right? So we are saying all these things in our daily life. Okay, so that means force, which thing we are now going to study, that is very much relevant to our daily life activity. Okay, and gravitational force, obviously always it is very much related to us, because whenever you are playing with football, after certain amount of distance the football will come to the ground, or you are just throwing the ball, basketball, so any playing games, at that time also gravitational force you can observe. Here you can see this boy, very good boy, and just he has one ball here, and he is standing on the chair and one ball, and here one feeder here. Okay, he has collected these things, I think, very carefully. So one ball he is just throwing, and one feeder also he is just throwing on the same height, approximately same height. And here the ball that is attracted by the gravitational force, it will fall. And if you observe very carefully this picture, you can see one thing. This feeder is in this position and this ball is in this position. See the position of these two objects. And what is the big difference between these two objects? The difference is that it is lighter than the ball. Okay. Same thing whenever you are just playing with a ball, this man is playing with your ball and just he is throwing the ball. You can see that this ball is moving towards the ground. So this one is our ground, moving towards the ground. And this person, what he has done, just slipped off. So here every object in the universe, whether small, large, exerts a force on every other object. And this force is known as a gravitational force. Here the gravitational force pulls this person down when he falls down on the floor. Yes, so gravitational force that pushes. So gravitational force, here there is some force acting due to the gravitational force. So gravitational force that pulls his downward. Okay. So this is the gravitational force. Always we are thinking that force means whenever you are just uttering the term force, you are thinking that I have to apply the force. I have to pull something or I have to push something. No, it might be non-living things that also exert forces. Non-living things like our earth. It exerts a gravitational force on all the objects present on the earth. That's why we are standing somewhere on the ground and we are just throwing one ball. After certain amount of the height, again the ball will come down to the ground. So these things will happen. And in our daily life, we are seeing that yes, the gravitational force that attracts our activities or our objects, right? Sometimes it attracts this person also, right? Here you can see this person, he is applying push force. Here, that what I have told you, sometimes whenever you are going to any shopping mall, at that time you can see one glass door where it has been written push or pull, or the symbol may be given like this. So in physics, force is defined as the push and or pull on an object with mass that causes it to change its velocity. Now, this thing is very important. Suppose I am applying some force. It might be my object will move. Suppose I have a block here. I am applying some force and it will just move some distance and after that it will come to rest. So this is the distance, how much it has covered, but this distance has been covered due to the force you have applied, right? So this is one block. The same block you are applying the force, and this block will be in motion and will move with a velocity v, and it will move the distance d, then it will come to the rest. Okay, so here it was in rest condition, you are applying force, then it will be in motion condition, it will move a distance, then again it will be in a rest condition. Now just remember one thing, whenever you are playing football and you are just kicking the football, after certain time you can see that the ball that will be in a rest condition after certain time. Okay, so that means I am applying the force, that's why the object is moving, and here it changes its velocity. And what is the velocity here? First, if it will be at the rest condition, then final velocity v, always we are representing final velocity as v, so v will be 0, and u, that is the initial velocity you are applying, right? So this is the force. Now whenever I am applying force, at that time another thing that is very important to take into consideration, that is the friction. Now first we are just going to elaborate this thing. Force is an external agent capable of changing the state of rest or motion of a particular body. Some body or some object, body means here object. Okay, so some object, just a minute, some object, it may be at rest and it is just moving some distance, or some maybe will come to the rest. That I have told you, I am applying force to the football, after certain distance it will come to the rest. Or it may be some block you have that is in the rest condition, some block you have that is in the rest condition, and it will move some distance, then it will be at rest condition again. So that means what? If your object is in rest condition, it will change its condition. If your object in motion condition, it will change its condition. It may be it will come to the rest, right? And the force has magnitude, also the direction. Okay, so and in the definition of the vector quantity, we have studied the magnitude and direction, both you have, then it will be your vector quantity. That means force, that is a vector quantity. So the direction towards which the force is applied is known as the direction of the force. Suppose I am applying the force, just a minute. Suppose I have one block here, I can apply the force in this direction. I can apply the force in this direction if I want to fall this one, or I can apply the force in this direction. So in which direction you are applying the force, that is the direction of the force. And the application of force is the point where force is applied. Suppose at this point you are applying the force. So this point is the point where the force is applied. So this is the point of application of force. This is the point of application of force, right? Now see this diagram. This is a block, and here some force if you are applying, and this is the ground, this one is your ground, and this one is our block, and here the surface, this surface this surface, in this surface, the block is attached to the ground. In this surface, another force is acting always, that is the frictional force. That is what? That is the frictional force. That is the frictional force. You can see that whenever you want to slide some block or some object on a very polished floor, then you have to apply less amount of force. But if you are just moving any object just on the ground, at that time you have to apply much more force. That is only due to the frictional force. Whenever you are moving the object, at that time you have to overcome the frictional force, because here you can see that the direction of the motion here and the direction of the frictional force in the opposite direction. So the force you have to apply, that will be higher than the frictional force, until unless your object will not move. Until unless your object will not move. So I have to apply that much force that will be higher than the frictional force. And this frictional force depends on a lot of factors. Obviously, among all the factors, one factor is very common and you can understand, the surface, right? On which surface you have kept the object. Now this is the spring balance. The force can be measured using spring balance. Here, this is the scale of the spring balance. So we can use spring balance to measure the force. Now the unit of the force. Here, common symbol we are using F. SI unit is the Newton, as per the name of Sir Isaac Newton, and SI base unit kg meter per second square, because force, later on I will teach this thing. F equals to ma. M is the mass. So mass is always represented by kg, and acceleration, that will be in meter per second square. So kg meter per second square. That's why kg meter per second square. And other units also you have, that is the dyne, pound, kilopound, etc. etc. Now F equals to ma, that I have told you. M is the mass of the object. Mass of object. And the A, that is the acceleration. Acceleration. If you are just throwing one ball downward, that means towards gravity, towards ground, then this acceleration will be g. If you are moving along any surface area, then it will be your different acceleration. Okay. And the dimension is the Lm t to the power minus 2. Here you know that here you have the dimension Lm t to the power minus 2, or t divided by Lm divided by t square. Now what are the effects of the force? First thing, you know that I am applying one force. Why you are applying some force? If one object is at the rest condition, you have to move it. If one object you have in moving condition or in motion, at that time you have to stop this, or you have to slow down this. At that time also you can use this. So to slow down any object, to move any object from rest, to stop any object, to stop any moving object, we can use this. Suppose the ball is going beyond the boundary. Just one player, he is just giving one leg fit, and you can see that the ball will stop, right? Or you can see that the ball, he is in a rest condition. Whenever he is just giving one force with his feet, at that time the ball will go somewhere, right? Or sometimes you are applying the force to slow down any motion. Okay. So it can accelerate the speed of the moving. Obviously, if any object will move from rest to motion, then it will, that means you are giving some speed. That means you are accelerating. It can also change the direction of the moving body along with its shape and size, right? So suppose you are applying some, this is the block, and you are applying some force here. So it will move here move towards this one. So this is the direction. This is the direction. Now, if you have the block here and you are applying the force here, then it will move in this direction. So this is the direction. So that means what? The force that can change the direction of the moving body. That can change the direction of the moving body. And sometimes you can see that the shape and size also can be changed. The shape and size also can be changed. Now the formula of the force. That already we have stated in the table, that force equals to mass into acceleration, and the unit is the Newton or kg meter per second square, and the force is the vector product of mass and acceleration. Okay. Now force acceleration here, force equals to m into a. M is what? Mass of the object. A is the acceleration with which the object is moving. Now you know that this may be written as acceleration is what? Velocity per unit time. So mv by t we can write, where v is the velocity, t is the time, right? So we can write the force is nothing but mv by t. So if they will give you velocity, mass, time, you can find out the force also. Another thing, that is the inertia, where inertia is nothing but it is represented by P, that equals to mv. And sometimes we are calling this is the momentum. So force also, that equals to P by T, or rate of change of momentum with respect to time. Rate of change of momentum with respect to time. Okay. So force is the mass into acceleration. Again, acceleration is nothing but as acceleration is v by t, velocity per unit time. So if we substitute this one, you will get mv by t. If we have to find out in terms of the momentum, then f equals to p by t, or the rate of change of momentum with respect to time. Now the unit of force, as I have told in the table, it is Newton, SI unit, and CGS unit is the dyne. CGS unit is the dyne. Just a minute. You should remember this thing. Sometimes they are giving MCQs from here. The SI unit, that is the Newton, and the CGS unit, that is the dyne. Newton, that is the SI unit, this is the SI unit, and this is the CGS unit. Dyne is the CGS unit. Now types of force. As I have told you, may be balanced force, may be unbalanced force. See this picture. You can remember anything? In your school, sometimes it may be this game also has been given to you. One where he's here, string is here, very strong string, and some of your batchmates, they are in this side, and some of your batchmates, they are in this side, right? And the equal force, 300 Newton, they are applying. So what happened? They are holding that string, but nobody will win. But if this left hand side persons, they are applying 400 Newton, and the right hand side persons, they are applying 300 Newton, in which side you are applying more force? In this side. At that time you can see that after some time, if it will continue, they will win. Okay. So here you can see that this is the balanced force. That means in these two directions, whatever the force has been applied, both are same. Okay. So if this is our F1, if this is our F2, so here F1 equals to F2. And if this is our F1 dash and if this is our F2 dash, so here F1 dash is greater than F2 dash. Okay. So this is the balanced force, the first example that illustrates balanced force, and this will be the unbalanced force. So what is balanced force? Balanced force, when it will be applied to an object, there will be no net effective force. As I have told you, net effective, just a minute, net effective force. In the previous diagram, we have seen F1 that was 300 Newton and F2 that was also 300 Newton, right? So the net force that is F1 minus F2 that equals to 0, right? So net effective force acting on the object here 0. Balanced forces do not cause any change in motion. Like I have told you, the left hand side friends, they will not never win, and right hand side friends also they will not win, right? Because both of them are applying the same amount of force, that is the 300 Newton. Now unbalanced force. Unbalanced forces that whenever you are giving on an object or acting on an object, then it's change its speed and direction of the motion. It moves in the direction of the force with the highest magnitude. Here, if we take the previous example, what was F1 dash? 400 Newton. And it was applied in this direction. And F2 dash, that was 300 Newton. And it was applied in this direction. So net force that equals to F1 dash minus F2 dash, that equals to 400 minus 300 Newton. 400 Newton minus 300 Newton, that is 100 Newton. And it will be in this direction. It will be in this direction. Okay, because this is the larger one. So this is unbalanced force. Now, like I have told you almost regarding the net force, but still I am just explaining this in very well manner. Suppose this is the block. Let's design this block. This is the block, and here 5 Newton and 5 Newton. So F1 that equals to 5 Newton and F2 that equals to also 5 Newton. So how much is the force you are applying in this direction? That is F1 plus F2. That means 5 Newton plus 5 Newton, that equals to your 10 Newton, right? So 10 Newton force you are applying in this direction, and 7 Newton force you are applying in this direction, as F3 equals to 7 Newton. Now net force that equals to F1 plus F2 minus of F3. That means 10 Newton minus 7 Newton, that is the 3 Newton, but it will be here. This 3 Newton will be in this direction. This is the net force. Okay, that means whatever the force you are applying in different direction, you have to find out what is the net force. Okay, so net force acting on a body can either change the magnitude of its velocity or change the direction of its velocity. Now remember one thing, if the net force F net that equals to 0, then there will be no change in the velocity or direction of the velocity. But if this F net that is high or value, some value, it has some value, at that time it has some impact on the velocity or magnitude. Okay, so for example, when many forces act on a body, the body is found to be at rest. That means whatever the forces you are applying, net force will be 0. Just now whatever I have told you, that if F net equals to 0, Suppose one body you have or one object. Body means object. I am applying force F1 here, F2 here, F3 here, F4 here. So F net, that is the F1 plus F2 plus F3 plus F4. If all these are 0, at that time you can see that your F net equals to 0. So the body will not move. The body will be in rest condition. Now types of forces. Here in the types of forces we have two types. One is the contact force, another is non-contact force. Contact force means I am applying with my hand. And non-contact force means I am not applying my hand. The force will be applied, but how? Without any contact, right? So here you can see that contact force. This is muscular force. Okay, just a minute. Again, I have to take the highlighter. So this is muscular force. Then mechanical force. Then frictional force, right? Frictional force. This is mechanical force. All these are contact force. Because you are applying your hand or your leg, but whatever the surface where you are applying the force, that surface is attached to your body part. That's why it is called contact force. So forces that act on a body either directly or through a medium are called contact force. Here you can see that through a medium I am applying force. Through a medium I am applying force. Through this medium I am applying force. But these are the contact force. It can be muscular, mechanical or frictional force. Muscular, mechanical or frictional force. Now examples of the contact force already I have described with the help of diagram. And these forces actually we are using for different purposes. Like if you want the muscular force, you can use to for bullock carts, for horses, for camels also. You can see that they are carrying one person. So at that time you can use the muscular force. Now what is the frictional force? As I have told you, if you want to slide this object through this surface, it may be your ground, it may be polished floor, whatever, through this surface, at that time there will be another force acting on the object, that is the frictional force. And here the friction is the force that resists the motion when the surface of one object comes in contact with the surface of another, right? So if one surface will be, this is the surface of the block. If one surface of the block is on the surface of the floor, then there will be some frictional force. That this frictional force always resists the motion. And if you want to move this, you have to apply the force that is greater than the frictional force. Until unless the object will not move. So here frictional force, you can see that someone pushing here the block and the friction is here. So if I tell one thing, that is the net force. Here the net force, that is actually whatever the pushing force you have, how much force you are applying to push, minus of the frictional force. What is the difference between these two? And if your pushing force that is greater than the friction, then the object will move towards this direction until unless it will not move. If your pushing force that is greater than your friction, then the object will move towards this direction. Always remember this thing. That's why if the frictional force is higher, you have to apply more force to move one object. If the frictional force is lower, you may apply very small amount of force to move one object. Okay. So frictional force, the mechanical advantage of the machine that is to reduce the friction. Here you can see that sometimes what we are doing, if heavy object you have, just we are taking one tray and where you have the wheel, and over that you are just keeping the block and you are taking out this in this direction. Okay, with a string you can push or you can pull pull this. Okay, so here we are using the frictional force, but we have to overcome the frictional force. That's why we are using some machinery. Okay, that will reduce the friction. And automobile uses 1/4 of its energy on limiting the friction. What you can see that in your car there are some wheels. If your car it does not have any wheel, at that time you can see that the friction will be very high. So it cannot move, or if it will move at that time the energy loss will be very high. Now it is also friction in the tires that allows the car to stay on the road, and friction in the clutch that makes it possible to drive. Now one thing very important, suppose someone is going with the car, with his car, someone is moving on the ice, on hilly station. At that time you can see that these tires will be manufactured in such a way that it will give you some friction, unless you see that whenever you stop the car, it will slide. So that's why the tire also it has some friction. Okay, and the clutch of your car, that will also help for the friction. Okay, to provide the friction. Now what is the frictional force? So frictional force that refers to the force that is generated, just a minute, frictional force that is generated by two surfaces that contact or slide against each other. Okay, so two surfaces are there, they are in contact or they are sliding against one each other, then this is the frictional force. Now several factors, previously also I have mentioned this one, several factors are there which will affect the frictional force, mainly affected by the surface texture and amount of force. Surface texture, I have seen that if this is the polished surface, over this you are keeping one object, fine. Now if you have this type of surface, at that time you can see that more friction will be there. If you are moving any object through a ground, it will feel more friction. There will be more friction, more force you have to apply to move that. If it is your floor, very smooth floor, at that time you can see that it will slide or it will move very easily with a small amount of force. Okay, so the angle and position of the object also very, very important. The angle and the position of the object. The angle and position of the object, it will affect the amount of the frictional force. If an object is placed flat against one object, then the frictional force will be equal to the weight of the object. Okay, so if suppose this is a table and over that you are keeping one object, so some W, that is the weight, will be acting here. So if you are placing one object, at that time you can see that frictional force will be equal to the weight of the object. If an object is pushed against the surface, then frictional force will be increased, becomes more than weight of the object. When I'm just pushing this against surface, then frictional force will be increased. Okay. Now the force of friction calculation. The maximum amount of friction force that you have, the object you have on a surface can apply upon an object can be easily calculated using the formula, that is the mu into F norm. Now, just a minute. Suppose you have this type of plane where you are keeping one object. So, if you want to slide this one, some normal force will be applied. So the frictional force is the coefficient, the mu is the coefficient that depends on the surface of this floor and F normal, okay, and the normal force. Here I have shown very clearly the normal force is the support force exerted upon an object that is in contact with another stable object. Here in this diagram, you can see that this is a slanting floor, okay, surface, and here the theta angle is there. Now we know that if this is the block, just a minute, this will be the block or body. Now if this block I want to slide down, and here, first thing, whenever it will be at rest, there will be some forces acting on this. The first thing, mg will be acting on this direction. Then if this is theta, then you can see that here this will be mg cos theta, this mg cos theta, and this will be mg sin theta. And the normal n, that will be in this direction. So here we can find out the n is the m into g. N is the m into g. Okay. So the normal force can be simply described by the formula, that is n equals to mg. Now here m is the mass of the object or the block, and g stands for the acceleration due to gravity. Acceleration due to gravity. So if you have 2 kg block, then what will be your normal force? If you have the normal force F normal, that equals to m into g. If you have 2 kg, then g is how much? 9.8 meter per second square. So it will be your total normal force, and it will come 19.6 Newton. Okay. Now, how you can calculate the force of friction? Force of friction. Suppose you have inclined surface, right? So if you have inclined surface, the strength of the normal surface, here the strength of the normal surface is reduced the more the surface is inclined. Hence, here the n will be mg cos theta. Here n will be mg cos theta. Now, if you have the angle theta, if you have no angle here, only some body will be, you are keeping the body on a plane surface, at that time it will be mg, where theta is the angle between this inclined surface and the plane. Okay, so this is the theta. Now, the coefficient. How to find the coefficient? Static friction is one point, another is the kinetic friction. So the coefficient of the friction, that depends on the object for any specific situation. That means your block is where? It depends on that thing. If the object is not moving at that time, that means your object is not moving, means what? Your object is static, right? It is standstill. So at that time we have to apply, that is mu static. That is mu static. Whenever I am just applying one inclined plane and the object that will slide down, at that time you can see that here you have to apply mu slide. Here you have to apply mu slide. Here you have to apply mu slide. Okay. And whenever static friction has been applied, at that time your whatever force, the static force, that will be mu static into m into g. Whenever it is your sliding, at that time you have to apply mu slide. Okay, different coefficients for different conditions. Now, type of material, according to that, our static friction and kinetic friction all are different. Suppose rubber on dry concrete. At that time, static friction is, static means whenever it is standstill. Static friction is 1.0. Whereas it kinetic friction is 0.7. When you have metal on the wood, 0.5, and kinetic friction is 0.3. Here ice on ice, right? Here 0.1, and here the kinetic friction is 0.03. Steel on ice 0.4. Here 0.02. Right? So the type of the material used also affect the coefficient. It is not that always, that means from this table we can see that your object is what type. That is one important point. Another point is that on which surface, what is the type of surface where you are moving your object. That is also very important. If a block was on the brick surface, the coefficient will be 0.6. If the block of clean wood, then ranges will be 0.25 to 0.5. Fine. So remember one thing, your type of material, that means your object material is important, as well as your surface material is also important. You are rubbing on which, that is also important. Now, the calculating the frictional force, as I have told, F equals to mu into N. Here, F that equals to mu into N. So, if 2 kg resting on a table, coefficient is 0.5. So, here it will be 0.5 into mg, because N equals to mg. Okay. That means 0.5 into 2 kg into 9.8 meter per second square. Okay. So you can find out in this way what will be the value of the force if you are keeping 2 kg of weight or 2 kg block on any surface where the coefficient, frictional coefficient is 0.5. That means here it will be 9.8 kg meter per second square. Okay. So here the answer will be 9.8 kg meter per second square. Next, some MCQs. Let's do it. Which of the following statement is not correct? Here you have to read the question properly. Not correct. For any object moving along a straight path in an accelerated motion, a force is always acting on it. Okay. So this is not correct. The inertia of an object tends to cause the object to resist any change in its state of motion. Always we are applying the force to overcome the inertia. Inertia is the basic property of any object, right? So we have to overcome this one. So that's why to resist any change in its state of motion. A passenger in a moving train tosses a coin, fine, which falls behind him. It means the motion of the train is accelerated, uniform, retarded along circular track. So the train is accelerated. Okay. Next question. A large block of ice is being pulled across a frozen lake. The block of ice has a mass of 300 kg. The coefficient of friction between two ice surfaces, mu k equals to 0.05. What is the force of friction that is acting on the block of ice? Just a minute, I am taking another color to solve this problem. What happened? Just a minute. Okay. So here, as I have told, always I am just telling one thing. What are the given data? First you write down all this. Here it has been given mass is 300 kg. So given data F is the mass, that is 300 kg. Okay. Mu K, that is the coefficient of friction, 0.05. 0.05. So we have to find out what? The force. Now you know that the force is nothing but mu into N, where mu is the coefficient of friction and N is the how much will be your mg. Okay. So we can write down mu into m into g. So we can write down here 0.05 into mass is how much? 300 kg. G is how much? 9.8. You have to remember this thing. 9.8 meter per second square. So it will be 147 kg meter per second square. Or you can write down, this is also may be represented as 147 Newton. Okay. And this is the answer. Thank you. So these are the force and types of forces.